It is May 1940, and President Franklin Roosevelt just asked America to do something impossible. Build 50,000 combat aircraft every single year. America is not even in the war yet, but someone needs to figure out how to build all those planes. So, in January 1941, Ford executive Charles Sorensen flies to San Diego to see how Consolidated is building B-24 bombers. He is absolutely horrified by what he sees. He says, "You guys are building these planes like a tailor cutting a custom suit. No two planes are exactly alike. How are we supposed to mass produce these?" They answer, "Well, that's just how we build planes. Every plane is a little different." Sorensen says, "This is never going to work. We need to build these like we build cars. Good luck with that." Sorensen goes back to Henry Ford with an idea. What if we built the biggest factory in the world and turned bombers into an assembly line product? And so, in 1940, construction begins on a giant factory near a little creek named Willow Run. It is 35 miles west of Detroit, basically in the middle of nowhere on farmland. Architect Albert Kahn designs a massive building with 3.5 million square feet of space under one roof. The assembly line is mile-long. It is the largest factory anywhere in the world. The building is shaped like an L, which creates a problem. How do you move airplane fuselages around a corner? Easy. You install two giant turntables to rotate the planes 90 degrees. They also build an airport right next to the factory with 6 runways, because where else are you going to park hundreds of bombers? The whole thing costs somewhere between $47 million and $90 million, and the government chips in another $200 million for the overall project. But there is a big problem. The engineering drawings from Consolidated are completely useless. They are incomplete, filled with mistakes, and use strange symbols that Ford engineers do not understand. Most of the specifications only exist inside the heads of Consolidated's workers. So Ford does something crazy. They have 2 B-24 bombers flown to Dearborn, and they take them apart piece by piece. A team of 1,000 people works around the clock for almost a year to create detailed blueprints of all 30,000 separate parts. They generate 5 million square feet of drawings. Originally, Ford was only supposed to make components and ship them to other companies for final assembly. But by October 1941, Ford receives permission to build complete airplanes. The plant opens in September 1941. That is 2 months before Pearl Harbor. Now it is time to see if this crazy idea actually works. At first, things don't go so well. The first bomber takes months to build, but Ford knows how to build things on assembly lines. So they break the B-24 down into 11 major assemblies. Then they break those down into 69 sub-assemblies. They develop a precise build sequence and standardize everything. And it works. By 1944, Willow Run is rolling a B-24 Liberator off the production line every 63 minutes. That's 1 bomber every hour, 24 hours a day, 7 days a week. In April 1944, they hit peak production. Willow Run produces 428 bombers in a single month. Between April 24th and April 26th, 100 completed bombers fly away from the plant. That's 100 planes in 3 days. By the end of the war, Ford has built 6,972 B-24s out of the 18,482 total that were made. They also ship out kits for another 1,893 planes. By 1945, Ford is producing 70% of all B-24 bombers in just 2 9-hour shifts per day. And remember, each B-24 has 450,000 parts and 360,000 rivets. At peak production, 42,000 people worked at Willow Run. And here's where things get interesting. We needed more workers, but most of the men were fighting in the war. What about women? Could they do this job? Let's find out. About 12,000 women went to work at Willow Run. They were paid 85 cents per hour, the exact same wage as the men. One of those women was Rose Monroe. You might know her as Rosie the Riveter. She actually worked here. Willow Run also hires significant numbers of African Americans. The plant has on-site training classrooms where workers learn specialized skills like riveting. But most of the tasks are simple and repetitive. You can learn them pretty quickly. So, what made Willow Run work? Well, it helps when you have one product and one customer. The United States government had an unlimited budget, and it used cost-plus contracts, which meant Ford made a guaranteed profit. The government actually financed the construction of the factory. And if any supplier could not keep up with production, the War Production Board could seize their plant. On May 27, 1941, President Roosevelt declared an unlimited national emergency. That meant the government could force any business to accept war production contracts. So, if it worked so well back then, why could we not do this today? Let's compare the B-24 to a modern fighter jet. The B-24 had 450,000 parts. Most of them were mechanical. The systems were analog. Pretty straightforward. Now look at the F-35 fighter. It has millions of lines of software code, advanced sensors, stealth materials, and precision manufacturing, where the tolerances are measured in microns. That precision is incredibly tiny. Want to know how many F-35s America can build per year? About 150. That is the maximum production capacity. Here is some math. During World War II, America produced 300,000 planes between 1942 and 1945. At current F-35 production rates, it would take 2,000 years to match that output. So, why not just make simpler planes? Because the enemy also has technology. You cannot win a modern war with simple planes. But there is another problem. Building a single modern military aircraft requires thousands of different manufacturers and suppliers. And that creates all kinds of problems. In 2022, the Department of Defense had to halt F-35 deliveries. Why? Because someone discovered a Chinese-made alloy in a turbo machine pump. The alloy had passed through 4 levels of suppliers before anyone noticed it. Wait, are you saying there is Chinese metal in our stealth fighter? Yes, but we only found out after it went through 4 different companies. How did nobody catch this earlier? Good question. Here's another issue. If only one company makes a critical part and they have problems, your entire production line stops, and America's defense contractor base keeps shrinking. In 2016, there were about 69,000 companies. By 2020, that number dropped to 55,000. During World War II, Ford mostly controlled its own supply chain or worked with just a handful of major suppliers. The War Production Board had almost unlimited power to control resources. If there was a bottleneck at any factory, the government could just seize it. During the war, civilian car manufacturing simply stopped. No new cars for anyone. Try doing that today. And then there are all the regulations. Today, if you want to build something for the military, you have to follow the Buy American Act, the Berry Amendment, environmental regulations, OSHA workplace safety standards, the Federal Acquisition Regulation, cybersecurity requirements, export controls, and quality assurance documentation requirements. In 1941, the paperwork for building a bomber was maybe this thick. Today, the paperwork is thicker than the bomber, but we are not done yet. There are even more reasons why this will not work today. During World War II, the economic model was simple. Ford had one customer with an unlimited budget. The government used cost-plus contracts which guaranteed profits. There was no competitive bidding required for most contracts. The government paid to build the factories. Nobody cared about quarterly earnings reports for shareholders. Today, everything is different. Contractors and subcontractors have complex agreements that make it hard to fix problems. If there is an issue with a subsystem, good luck getting everyone to cooperate and solve it. Modern weapons take 10 to 20 years to go from concept to actual production. Programs get canceled all the time. Budgets get cut constantly. The focus is usually on cutting-edge performance, rather than whether you can actually build the thing. Then there is the workforce problem. During World War II, many workers were drafted into service or desperately looking for any job. Unemployment from the Great Depression meant people were willing to work. The tasks were simple, and you could learn them fast. The government even provided housing and transportation for workers. Today, there's a labor shortage in defense manufacturing and naval shipbuilding. The skills you need require years of training. Commercial companies compete for the same skilled workers and usually pay better. The workforce is getting older, which means all that knowledge is disappearing. America's manufacturing productivity actually went down between 1941 and 1948. The country learned how to build planes and tanks efficiently in 1943. But those gains faded by 1944 when production shifted to heavier and more complex items like B-29 bombers and Pershing tanks. The skills did not transfer to peacetime manufacturing at all. The whole strategic situation is different too. World War II was an existential threat. Everyone agreed on what needed to be done, and people were willing to sacrifice civilian production completely. The government could redirect the entire economy. Today, we have a peacetime economy where people expect to buy stuff. Supply chains are globalized, and we depend on countries that might become our enemies. There is zero political will to impose World War II levels of economic control. Modern weapons are designed completely differently. The priority is maximum performance, not ease of production. We seek technological superiority over large numbers. Complexity often wins over simplicity. Customization replaces standardization. The B-24 was designed from the start to be mass-produced. Modern weapons are designed for performance first, and someone figures out how to build them later. And here is the big one. China's manufacturing dominance is a fundamental problem that cannot be fixed with small improvements. Experts say we only have about 3 to 5 years to transform our defense industrial base before it is too late. So, what happened to Willow Run? After the war, Ford decided not to buy the plant. Kaiser Frazer moved in and built 739,000 cars between 1947 and 1953. Then, General Motors took over and used it until 2010. Most of the factory was demolished in 2014. A small piece was saved for the Yankee Air Museum. The lesson here isn't that we need to recreate Willow Run. Modern production needs completely different approaches. Additive manufacturing, modular design, software-defined factories. Maybe we need simpler weapons that we can actually build in large numbers alongside our high-end systems. The question isn't whether we can build another Willow Run, it's whether we're ready for what comes next. Subscribe for more videos.